welcome back. If you want to add more to your knowledge about power system, this is what you want to follow. If you haven't watched our previous video and want to know that what we will be covering in our course and what has already been covered, make sure to watch our previous video. Efficiency. If you remember from our previous videos, we have said that energy exists in different forms in nature. It could be the pressure head of water, chemical energy of fuels, or nuclear energy of radioactive substances. We have also said that all these forms of energy are interchangeable among themselves. And if you remember the basic principle, it says that energy is never wasted, but it gets converted from one form into another form. Now, when we are converting one form of energy into another form of energy, some energy get lost in the process of converting energy sources. That is why we have efficiency. The output energy divided by input energy, or output power divided by input power, is called efficiency. And that brings us to the end of our Unit 1. Before we jump up to some exercises to be solved, please make sure that you have watched all our previews of Unit 1, which are importance of electrical energy, generation of electrical energy, sources of energy, comparison of energy sources, units of energy, and efficiency that we have just discussed. Let's have a look into some examples to be solved. As of our first example to be solved, we are dealing with a situation that we deliver or we give a mechanical energy to a DC generator of mechanical energy of 5200 joules per second. And our generator converts the mechanical energy into electrical energy by delivering 25.5 amperes of current at a voltage of let's say 110 volts. Now let me go to our second page, that efficiency is equal to what and how much power is being lost. So PL, so it's a power loss, that how much power is lost. So now that we have all the data and we know that what we are required to find out, so let's have our solution for the problem. So we have that our input power is equal to PI. Input power is equal to 5200 joules per second, and that's also equal to 5200 watts. And our output power will be PO, that's our output power. It will be equal to, our output power equals to V into I, and we have the data that V into I equals to 110 volts into 25.5 amps, and that equals to, the answer is 2805 watts. So this is our output power. So now that we have found out our output power, we are one step closer to find out what we are exactly required to find out, and that's the first thing is output energy percentage. So let me go to another page. Okay, here I have to clear this thing out. We are to find out efficiency. Okay, now we have said that efficiency is equal to output power divided by input power. So, and that's equals to, let me enter the data. Yes, and after putting the data and doing some calculations, we have find out that the efficiency is equals to 53.5%. So now let's find out that how much power is lost during the process of conversion of mechanical energy into electrical energy, and that is PL, that's power lost, equals to PN minus PO, that's output power, and that equals to, after putting the values in instead of PI and PO, we get that our power loss equals to 2395 watts. Now, if we want to find out that the amount of energy lost per minute is, so we have to multiply our energy lost, multiply the power lost into times t, and it will be in terms of seconds. So this equals to, so now multiplying our power loss, that is 2395 watts into 60 seconds, and this will give us, okay, I'm gonna write it here in above, it's 14,3700. Okay, now this is the amount of energy lost per minute, and this is obviously in joules. We will have some more examples in our next video. Thank you so much.